okay, times with cos Pn, okay, x, I get a Pn first, okay, plus, okay, close, plus sine Pn x Pn squared overall 10 over 0. Okay, see, I haven't substituted yet. Let me settle with this, all these things yet. This, okay, you see, I want to make it the same Pn taking out. Okay, therefore I'm going to do this. Then standard, the model is very much standard. I'm going to do this. Negative x Pn cos Pn x, okay, bracket plus sine Pn x, 10 over 0. Okay, now you open the Pn. That means you go back, okay, bring the 5 into this equation, okay, 5. From 5 we know Pn is okay, we know the Pn is n pi 20, right? Now you change. Why I'm doing this? There is a good reason, you can see later. See, now I'm handling this very conveniently, okay. See, why am I using the Pn here? Okay, you can see I times with the Pn, the Pn must go up here. I just taken out the whole thing here, put it here, just nice. I just add one more here, Pn, okay. You see what is the equation? Look very straight. Therefore when you substitute, you know exactly what you are doing. Okay, now you see I'm changing the whole equation. 1 to the 10, okay, here 20 n pi power 2, okay, this, okay, this one is a 40, 400, then you can cut and whatever that you can do outside, but you look at here, okay, look at here. The first round I'm going to substitute one by one. When I substitute, look at this one first. Before I substitute, you know, if you do this, it's easy. X, some of you say, sir, why are you doing this? Wait, there is a good reason for me to do this. Pi, okay, cos Pn 20 and pi x, okay. Some of you may have a different style, but I strongly recommend this way. You'll know why later, okay, x, okay, because solution is important. Finally you should be able to solve the whole thing. Okay, now you see, when you substitute here, you can observe what is going on. Okay, this number is coincident. Sometimes you will get a very complex, you know, for you won't be able to handle. Therefore carefully you place inside. Okay, now what I can do, you see, when I substitute this 0 and 10, what is going on here? It's something wrong. Oh, Pn is, oh, okay, here is a 1 over Pn, very sorry, n pi, n pi, opposite lah. Okay, very sorry, this is n pi, that's why I wonder what is something wrong. This is 20, this is n pi, this is 20, okay, n pi 20, okay, sorry, okay. Now in this case, this one is over Pn, then I just copy this one already, sorry. Okay, now you can see this, when I try to place here 10, look at this carefully, okay, 10, okay, the first one 10, no problem, I can substitute here, no issue. Here 10, I get this, see, this one I simplify first, simplify, 40, this n power 2 pi power 2, okay, hopefully you can see this, n2 pi 2, okay, the first one, the 10 will go in, okay, the first one 10 go in, okay, when it go 10 here, okay, negative 10, 20, therefore I make it a cut here, I get a negative n pi 2 cos, okay, I place 10, I get a n pi 2. Do you agree with me? Yes. Okay, straight 10, finish. Okay, when I place here 10, this one also will work, right? 10, I place it here, sine, yes. Please copy first, n pi 2. Okay, still no problem. What about 0? When I try to bring it here 0, 0, whole thing disappear. When I place 0, 0. Okay, done. Wow, straightforward. Don't change yet anything, don't change anything. This equation, keep it. Okay, this so far you got the equation ready. Then you want to bring inside or you want to cut it or whatever. Okay, don't do further. You can keep it here itself also, no problem. But I'm just showing, okay, the end product of this. Okay, 20 n pi cos n pi 2, 40 n 2 pi 2 sine n pi 2. Okay, okay, done. Keep it this for a while. Okay, now done. This portion clear. Okay, now I go to the I2, this one, I2. Okay, I show you I2. The I2, in order to solve the I2, camera also is very sensitive, isn't it? It's taking some time. Come back. Because I pull the paper bit. Okay. 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 I'm adjusting bit. Okay. For the I2, 20 to the 0, okay, 20 to the 0, 20 minus x, 10 sine Pn dx. Okay, again you use this method, 20 to the x, 10 sine Pn x, x missing, Pn is x. Okay, Pn is x missing. Okay, now this one same, negative cos Pn x, Pn, same, negative sine Pn x, Pn power 2. What about this? Negative 1 over 10, this one is 0. Can you see that? Okay, only small difference inside the changes, yeah. Okay, now same as previous. Okay, therefore you just times here, you will get 20 minus x, 10 cos Pn x, Pn sine Pn x, 10 Pn2, 20, 10. See, I'm making the concept is easier for you to work with. Similarly, you take out the whole 10 here. I just say here 10 Pn, okay, power 2. Okay, I make it this power 2, therefore Pn will go up. Therefore, you will see the equation become like this, negative 20 minus x Pn cos Pnx minus sine Pnx. Can you see that how I'm trying to work with the Pn first. Okay, Pn, okay, up to here can follow. Okay, now your task is to place the 20 and 10, but you are very smart, you know already, 20 go, this is gone. Okay, and 20 will go here, gone also. Why? I'll tell you the first 20, it will make the things disappear. Okay, but we change it back again as here. And 2 pi 2, same. Okay, you see when you check the whole thing, Okay, when you check the whole thing, you will get the negative sign and pi, okay, for the 10 and pi. If it is 20, go in here, 20, this is n pi, you know already, n pi is 0, no point we calculate that, right? Okay, but what about the 10? When I place the 10, then 10 play the role. Okay, 10 minus 10, then I get a n pi 2 cos n pi 2 plus sine, okay, n pi 2. Okay, this simplify, this is 0. Okay, can you see this? This is 0, n pi. Therefore, only come back to this again. We have done. Okay, when I simplify back, I get a 20. Okay, this, see, I didn't change anything. Please don't try to change anything. Just see there, and can I move further before I do anything here? N pi 2. Okay, can I combine these two? I1, I2. Can you see the similarity here? This is I1. This is I2. If I add these two, this one disappear. Can you see that? And I will get only these two. Can you see that? Okay or not? Okay. Okay, if I say go back to my original Fn, then Fn equals to I1 plus I2. Okay, over there when I plus I1 I2, I get 80 n 2 pi 2 sine n pi 2. Okay, then I bring it the 10 here, which is here, Fn become something very simple, 8 n 2 pi 2 sine n pi 2. Okay, now can I substitute this in F2? That's why I'm saying, do whenever you handle Fourier series, handle that step by step. Don't desperately go and change very fast. You see, if you can find the pattern to handle the problem very easy, okay, some of you may say, can I directly substitute ng, and it's look very complex. Here you see, I'm just lumped together the whole answers, the Pn, you know, easy for me. I just bring it out. Okay, I have tried several times for the complex scenario also. This is very helpful. Okay, after that, you know, you go back to the equation again. uxt equals to n equals to 1. Okay, sine pnx. Okay, you need to place this whole thing, right? This whole thing, 8 and 2 pi 2. This whole thing will go. Pn, I think same, Pn still same, but you need to add this together. You need to add this sine and pi 2. Okay, and some of you say, sir, can I change it this to 8 and 2 pi 2? This is negative 1 and minus 2, and minus 1 2 for the odd, right? 0 for the even. Can I change this and place it here? Hold for a while. Hold it for a while. Don't yet. Okay, just keep it, because we wanted to settle everything. Then you can show your skill here. Okay, not here itself. Don't place it here. Okay, for a while you just on hold for this part. Okay. Okay, here then you can show the cos p and t. Okay, gn sine p and t. Okay, since we know ut x equals to 0 is 0, therefore it's produced the gn equals to 0. Therefore when you go and handle this, you get a xt 8 n2 pi 2 equal to the n equals to 1 sine n pi. See, I haven't changed yet, huh? Some of you say, okay sir, now can I change? Can. On hold for a while. X cos pnt. Okay, now pn still I haven't changed, okay, but at least we know this one is there. Okay, now you can combine to work with this, okay, if it is for the negative 0 whatever, but at least you can solve up to here your solution, okay, or you can show your solution up to here. This is the well done work, okay, this is a well done work, okay, that's what my interest is. Okay, we have done the wave equation. I've given a one good example as well. I hope that you can do the rest of the question by your own. It's a matter of practice, then I think you can solve it by yourself. Okay. Okay, with that I end my tutorial here. Okay, the next part that I am interested to teach you is numerical, okay, PDE numerical, and remember your quiz will be given for the Fourier series. Okay, I'll give you quiz for the Fourier series. Okay, be prepared for that as well, and thank you very much.